What if you could test your AI models as easily as your code? Meet DeepEval, an open source LLM testing framework that is changing the way developers build, test, and trust large language models. DeepEval lets you peek under the hood and make sure the LLMs you develop are accurate, safe, and reliable before you ship them to the world. Today, we are doing a deep dive into this tool that could be called as a pytest for LLMs and that is powering more than 500,000 downloads every month. Hi, I am Ashish and welcome back to Coders Academy. DeepEval is an open source framework designed for testing and evaluating large language models. Whether you are building chatbots, RAG pipelines, or agentic systems, DeepEval gives you a plug-and-play toolkit to measure everything from accuracy to hallucination, even toxicity. Before we get started in this video, make sure that you are subscribed to the channel. If you like the content that we make, please do not forget to hit the like button and let me know your thoughts in the comment section. So let's proceed with today's video. For this tutorial, we will be using Google's Gemini 2.0 Flash model along with UV and VS Code as a development environment. Make sure that you follow all the steps that are mentioned in the video because it could be quite tricky to come back on track and debug the issues that you might face. So to get started, we will first create a projects folder. So we'll name it as make directory demo DeepEval. We'll cd into this particular folder and then do a UV init. So this initializes the project and creates the directory structure along with virtual environment. Now we will add the DeepEval dependency. So we'll allow the dependencies to get installed. So it's installing, so it's completed the installation of all the packages and dependencies. Now let's add other dependencies like pandas, numpy and pytest. It's installing. Let's wait for some time. Done. Okay. Now let's go to VS Code. We see the directory structure here for the project. This is a project toml file. We can see the dependencies there with the versions. And we can also see the virtual environment containing all the necessary libraries installed already. Now we can verify our installation of the DeepEval using this UV run python -c import and then print a message statement there. So let's run this command. Yeah, it has printed the message correctly. DeepEval installed successfully, which means the installation is successful. Now we forgot to add the Google dependencies, so let's add that. UV add Google generative AI. So it's installing the client. Yeah, installed. Now this step is very important. This is the step via which we can configure the Gemini model using CLI. So UV run DeepEval set Gemini, the model name and the Gemini API key. Once you have run this command, this is the message you should see as successfully installed. Before I explain the code, let me show you what I have done here. I have created a test folder. Inside that I have created a basic file called testbasic.py and I have added this test case inside this particular file. So before I explain the coding, let's run this once and then I will explain you what is happening in the code. So I'll go to the terminal. Okay, I already have this one over here. So I'll run this particular command UV run DeepEval, okay, and test run and then name of the test. Okay. So it's coming back with the response. You're running a DeepEval's latest answer relevancy model. So one test passed, 3 warnings, no test cases found apart from that. Okay. So let's study this response a bit. The score is 1 because the answer is perfectly relevant. Great job. And the success parameter is true. Okay. So now let's take a look at the test case that we have written. So these are the basic imports that you will require. From DeepEval require the evaluate model, metrics, test case. So here we are making use of answer relevancy metrics. Now this is the very important metric that the DeepEval framework provides. And then the second one is the LLM test case. Okay. So if you look at the documentation, let's look at the documentation once. So here is the LLM evaluation framework. If you look at the metrics and features section, here it gives you a large variety of LLM evaluation metrics are available, and this could be used to run the test locally on your machine. So what it's mentioning is these are the list of metrics that are available for different categories, for DAG, for RAG metrics, agentic metrics, others, conversational metrics and others, right? So here in this case, if you look, we are using this answer relevancy metric. Okay, so what we have done is we have created a simple test case here. We have done the setup. So if you remember any JUnits that you might have written, there are 3 steps to any test case. One is the setup, second is about execution, and finally is about assertion. So here what we are doing is we are doing the setup of the test case. So what we have done is we have taken the input text as what is the capital of France, and then we mention about the output. The capital of France is Paris, which is located to the northern part of the country. Then we do create an instance of LLM test case. Now LLM test case is a data structure which encapsulates the input text, the output, along with some optional context and other parameters. You can take a look at the LLM test case documentation. Like here is the source code also available. You can take a look at that, how it looks like. Once we have created the LLM test case, we have to define a metric. Okay. So in this case, as I told before, we are creating an answer relevancy metric with a threshold of 0.7. Why threshold of 0.7? Because this will allow us to understand the accuracy of the answers, and the model will give us the same value every time we question it. So it will avoid the hallucination and we will be able to evaluate our test case correctly. Then we do the execution part of the test case. Here in this case it is done as metric.measure. So this metric.measure, and then we pass the test case parameter to it. Okay. Now once the evaluation is run, it will return you certain values. In the answer relevancy metric case, it returns you score, success and reason. So these are the 3 parameters you get back, and that is what we have done in the final part of the test, which is the assertion. So we assert for the metric score of greater than 0.7. We check whether this success parameter is set to true, and then we print those values. And finally, this is the main method to invoke that particular test case. So this is what you saw here. You saw here in the response, the score is 1.0 because the answer is perfectly relevant and the success parameter is true. In case you are wondering how the test case is able to function correctly without configuring the LLM model or the API key. So if you recall, in the initial setup, we had configured the LLM model as Gemini, and we had also provided the API key via the CLI. In the trial, I realized that when you configure it via the CLI, the eval model, DeepEval model works correctly, but when you try to configure it via the ENV properties, it doesn't work correctly. So keep that in mind when you're doing your programs. In the second example, I have created a new file called testadvanced.py, and I have done the imports for the DeepEval framework here. So you'll start with having a hallucination metric, and we will also import the LLM test case. So I have created a function called test hallucination, and as I told you before, every test will have 3 steps: setup, then test, that is run the test, and finally it's going to be assert the test cases. Okay, so those are the specific steps. Now what we will do is, now we will create a fictional test, which is basically our test 1, for hallucination. Okay, so I will add a test here. So I have created this particular code where I have created an LLM test instance. I have passed an input, an output value, and some context. So this time we are passing a context to the test case. So what is happening here is, what is the population of Atlantis city? Now there is no place called as Atlantis city, and but still what we have done here is, we have provided the output here as Atlantis city has a population of 2.5 million people as of 2023. It is located in the Mediterranean Sea and is known for its underwater architecture and advanced technology. But in the context, what we have told is Atlantis is a fictional city. In Plato's dialogues, no real city called Atlantis exists in modern times. It's a mythological concept and no real place of that name exists. Now we will define our hallucination metric. So this is what we have given here, and a threshold value of equal to 0.5. We'll give a lower value because we are testing for hallucination. So this completes our setup. Now we will have to do the actual running of the test. Okay, so let's do that now. So in the example earlier, we saw that we run the test using this metric.measure method. Okay, so we'll copy that. So the metric is already defined here. It's hallucination metric. Okay, measure is here, and then we provide the test case. So this is our test case. We provide a test case here. Okay, so this will execute the particular hallucination test. Now the final step, which is assertion. So before we jump into the assert statements, let me first print the actual return values from the metric. Okay, so we'll have three statements here: print score, reason, success, and then we'll invoke the test method from here. Let's run this test and see what are the outputs we get for these three parameters. Okay, so we got a score of 1.0. The score is 1.0 because the actual output contradicts the provided context on multiple counts, including the existence and the nature of Atlantis, which is described as a fictional in the context but real with the population in the actual output. Okay, so the success is equal to false. So running teardown of this. So what it's done is, basically it is saying that the score is 1 because it is perfectly hallucinated. That is why the score value has come as 1. Okay, and the reason it has given that is because if you look here, we said that our actual output that the city has a population of so and so in 2023 and it is located in so and so area. But the context that was given was that it is a fictional city. So that is how this particular value is giving you a score of 1. So now we can basically do the assertion. So we can say assert hallucination metric score is greater than 0.5 or maybe 0.7. Okay, and the second assert we can say is hallucination metric success is false. Okay, so these are our assert statements. Now in case you were wondering how I am able to get this prompts, it is through one of the plugins that I am using in VS Code. It's called Super Maven. So have a look at one of my earlier videos on vibe coding, where I have detailedly mentioned about the usage and installation of Super Maven. Okay, now let's run the test again with the assert statements. So we'll do a clear console test advanced.py. This time the assertion should pass along with the test that we already have here. Okay, yeah, so it has passed because success is equal to false and it's a fictional concept. That's why the score is 1.0. Now let's try and do another test case. So this was about hallucination. Now let's do another test case which is about factual information. Okay, so what we are going to do is, we will just replicate this particular function here. Okay, and now what we will do here is test hallucination factual. We'll just rename it like this, and then we'll fill in the details and copy this here. So that's the invocation. Okay, and yeah, this is our test case hallucination, test case hallucination factual. Okay, so let's replace this parameter here. Okay, hallucination, then this is a metric, right? So hallucination actual metric, let's call this as hallucination factual underscore metric, and we'll copy this at all the places. So we'll comment out our assert statements first. Okay, so this becomes a metric, and now we just need to fix our input and the output. Okay, so let's fix this now. In order to fix this, what I have done here is I have taken some other information. So what I have done here is from the internet I just picked up some information around the city of Tokyo. So what I have said here, what is the population of Tokyo, that will be our input, and the actual output will be Tokyo has a population of so and so million in the metropolitan area of this area. It's the Japan's capital and the largest city. And now in the context also we have given the same information. Tokyo is the capital of Japan. It's a metropolitan area having 14 million residents, and Tokyo has the world's most populous metropolitan areas. So now this becomes our total LLM test case. We have a metric here where we have set the threshold value as 0.5. Okay. Now what we do is we run the test. So this is our metric, the measure the same as before, and this is our factual information. Let's call this as test case 2. Okay, and assert we have commented out initially, and we will only print the values of score, reason and success. So let's run the test again. Okay, just for the sake of understanding, let me just print here a separator. Okay, so that we can distinguish between the two test cases. Yeah, so the first test case is here, this is the second test case. So we are interested in the second part of the test case. So we come here. Okay, this is the second test result. The score is 0.0 because the actual output is fully aligned with the provided context and there is no contradiction. Success true and score is 0. Yeah, so as you can see, the score is 0, and the score is 0 because the actual output is fully aligned with the provided context and there is no contradiction. Success equal to true. So now we can fully align our assert statements here. Metric score is greater than, or rather you can even say equal to equal to 0, and metric success is true. Okay, we run the test again. Okay, so both the tests have passed and here it is in the same result. So that's how you can create tests, LLM tests using the DeepEval framework. That was your video for today. We looked at the DeepEval framework exclusively made for unit testing the LLM models. We saw all its features all the way from setup and demo test cases that we created. We wrote 2 test cases making use of the answer relevancy metrics and the hallucination metrics. Apart from that, we also saw that the documentation provides more than 14 different types of metrics. So do let me know in the comments what metrics have you used from the DeepEval framework. Let me know also your thoughts about this video and what new content you would like to see on Coders Academy. Thank you so much for watching.